Good to go? Okay. Okay. It looks like we're ready to get started here. Hello. How's everybody doing? Hey. My name's Nate Power. I'm a senior security consultant working at Rapid7. I've been doing penetration testing for approximately 5 years now. My experience can range from network security to application security all the way down to vulnerability research. A lot of what we're going to be talking about today is my main method on how I'm actually exploiting email systems to be able to extract credentials from these systems to essentially get onto the internal network over a VPN. A lot of what I'm talking about are some vulnerabilities that I have discovered and I had disclosed with Microsoft. Some of these issues had come back from Microsoft and they had said they are too architectural and they can't fix them, so they still exist, and I'm still actively exploiting these issues out in the wild. Okay, so our agenda for today, we're essentially following the pen tester methodology here of doing information gathering, trying to identify the systems on the network, identify vulnerabilities in these systems, penetrate, escalate privileges, and then maintaining that access. Majority of the talk today is going to talk through steps 1 through 4, but at any one time, I would say step 1, we're always in a constant state of information gathering. It's just something to keep in mind. Okay, some other types of information gathering we'll be doing. We want to know what our target email domains are going to be. We want to know email address formats. We want to know employee names. We want to know username formats. And we want to know where these mail systems are actually located on the internet. Then some of the more advanced information gathering that we'll be doing is we want to actually learn about the know the internal IP addresses of where these systems live on the internal network, identify the Active Directory domain, identify valid emails, and identify valid Active Directory usernames. Some of the attacks we'll be doing in this presentation is brute force password guessing. I'm going to show you guys the methods of how I actually approach that. And then we'll be going over several different email phishing style attacks. Then ultimately our end game here is to gather those Active Directory credentials. Okay, first thing, we want to locate the email domain and employee names. Locating the email domain, 98% of the time, pretty easy to do. All you have to do is Google the company name, and their primary.com is usually what they use for their emails. And if you're not able to find the email domain through some of these public resources, there are paid services like Jigsaw and ZoomInfo where they you can pay them and you can actually pull out information about an organization's employees and their contact information. Other public resources that I'm using to gather employee names, I'm using the Google and LinkedIn and Facebook are probably the most common methods for me. And I got a series of scripts that scrape these sites. Line item number 3 there, I'm seeing quite a bit of universities and law firms will actually have their entire employee directory online, which makes it pretty easy to identify employees. I find employee names within metadata and Office documents published on the internet. And then some maybe unlikely data sources that people don't think about is I'm getting data from the government to where we've requested Census Bureau data, and we have the most common first names and last names in America, and we are using voter registration data, and there's a lot of states in our country that actually provide this information for free. Okay, an example number 1 there, just it's an example. It's showing me I'm doing a Google search specifically at LinkedIn, and one of the scripts I have basically scrapes Google, try to identify employees that work at organizations. In this case here, we're able to locate someone that worked in HR at Rapid7. And in this next example here, I'm just using FACA to locate metadata inside these Office documents. And in this case here, You can see there's an actual username within the metadata here, to where I would say this is probably my #1 way to help me try to do a best guess of what a username format might be within an organization. Okay, next we're going to talk about SMTP servers. So SMTP servers are essentially how mail routes on the internet. You're going to have your external-facing internet SMTP services. Most organizations have their back-end exchange SMTP services that communicate with the external internet-facing systems. These are pretty easy to discover, the external systems, because there's DNS records out there. The MX records are designed so you can find these services. I would probably say lately, just from my experience, it's probably been 50-50 if the external SMTP services are actually third-party hosted versus a company actually running an SMTP server within their internet address space. Sometimes these SMTP services have useful information in the banner still. It's where I found naming conventions to computers, or maybe even Active Directory domain names within the banners. But most of the time, I'm not finding too much necessarily. And then I always check the configuration of these systems, because there's a receipt command in there that will help me validate if an email address actually exists in the system or not. Okay. In this example here, I'm manually testing the configuration of this SMTP server to see if it's going to allow me to enumerate valid email addresses from the system. Here you can see I'm just using the telnet command, connecting to the SMTP service on port 25. And I come down here to my receipt commands, and I see if jsmith@r7.com exists in the system, and it came back with a response of 250, recipient okay, which means this email account is valid. And then I, on purpose, put in an email address that I know for sure doesn't exist in the system. And email doesn't exist at r7.com came back with a response of 550 invalid recipient. Okay, which this is great because, you know, spammers love this because now they know an actual email address. But this is also one of the reasons why we got a lot of spam controls out there these days. And it's quite common to where if you're going through massively trying to enumerate valid accounts out of these systems, to where you will run into rate limiting, and your IP address will be blocked for an X amount of time. You know, and if that's the case, I have run into situations to where there's multiple SMTP servers set up in the MX record. Those SMTP services aren't correlating events between each other, to where I might get blacklisted on one, but then I could just jump to the next one on the list and continue my attack. Okay, so now that we covered the front-end SMTP services, let's talk a little bit about the back-end. One of the things I do when I'm on an assessment is I just write an email to an account that I know doesn't exist within the email domain I'm targeting. Sometimes I get these email bounce back messages, and this actually works a lot like the receipt to command we were just looking at. But this is the back-end SMTP service handling this communication. Looking inside the headers of the bounce back email addresses, we can figure out how the mail routes. Most of the time we can figure out what type of mail system it is. And in this case, it's a Microsoft Exchange server. Sometimes Active Directory domains can be held within the headers, or internal host names or naming conventions, or even the internal IP address to the backend SMTP server. Okay. Let's talk about the webmail services. And for this, we're primarily talking about OWA. Okay. So for OWA, that's actually one of many services running on a client access server that communicates with the backend Exchange systems and Active Directory domain controllers. Microsoft had built-in service along with the OWA called the Autodiscover service. And what the Autodiscover service does, it makes it so it's really easy to find the OWA on the internet, essentially. I don't know if you guys have ever set up an account in your email client to where it's sitting there asking you just to punch in your email address and your password, and then it goes and it finds your OWA and it automatically configures your email client and you don't have to do anything else. Well, that's what the Autodiscover service is doing. Okay, how it's doing this, it's and how I had determined this, I'd actually manned in the middle of the traffic between an Outlook client and an OWA. And then I went and found all this documentation on it online. But how it's actually finding the Autodiscover service is it's looking at static URLs, doing blind post requests to these two guys here. And then it's actually doing a DNS service record lookup. Okay, so I took these two methods here, and I had combined them with some common methods already known on the internet, which would include DNS brute forcing. I was looking inside SSL certificates, trying to identify mail systems that way, and I ended up finding out of a sample size of 500 different email domains that the static URLs tended to be the most common method for discovery. Okay, I'm going to show you guys a demo here. Oh God. Probably kind of hard to see, isn't it? You guys see that in the back at all? Yeah, okay. All right, so I had essentially wrote a shell script that goes through every one of those discovery processes. I just wanted to show you guys how quick it is for me to be able to discover OWAs on the internet. So all I did for this bash script was punch in the email domain, and then it's going to go through the discovery phase, try to find these OWAs. So it's going through, it did the static URL lookups. It was attempting to look up DNS service records, the DNS brute force, and then it actually ended up finding a host name in one of the SSL serves. So it's quite literally that quick for me every time, and most organizations have this set up and configured. Okay, so one of the vulnerabilities I found within the OWA webmail system, I found a method to be able to extract the internal IP address out of the OWA. Essentially, what I found was evaluating very specific IIS file paths. When I would send a GET request to these file paths with an empty host header, that this actually confused IIS, and it was coughing up the internal IP address to the client access server within the basic auth header. And I've also seen it within the location headers. And this is pretty much every OWA version is vulnerable to this. Here's all the initial file paths that I found vulnerable. It's where in the Metasploit module that I published, I think there are a few more file paths out there. Okay. And then I'm going to show you guys a demo how I found this manually using the OpenSSL client. Okay. So that very top line there, using the OpenSSL client in Linux, we're connecting to the OWA port 443. We make the connection, and just for kind of a proof of concept, we're doing a GET request to, and we're putting in a host name that's just made up. I just made it up, and we're going to see what happens. Okay, we see the made up host name that I put in there got put into the basic auth header, and it says pwned. Now I'm doing a request with no host name whatsoever. It confuses the system, and now the internal IP address to the client access server is listed there. And I ended up finding out if, let's just say you have more than one client access server and you might have put them into a farm. If you repeatedly run this command over and over again, you'll start bouncing between the different client access servers and gathering all their internal IP addresses that way. Okay, so right now we did the bounce back email. We know the internal IP address to the backend exchange system, and now we know internal addresses to the client access servers. So just kind of noting that information and moving along. Okay, so what we actually need for our brute force attacks, we need 3 key pieces of information to be able to extract these AD credentials. We need to know the Active Directory domain name, we need to know valid usernames, and then we need to identify weak passwords those usernames or accounts are using. Okay, so let's talk about how I'm identifying the Active Directory domain. So, by default, there's several of these IS file paths on the OWA that support NTLM. So NTLM over HTTP, it's still a challenge response protocol to where if I were to send an authentication request to the system, the response back that we would see would be this top picture. And it would basically essentially say 401 unauthorized. And the www authenticate negotiate gives me a big long string of base 64 back. And when we go to decode that, it actually has the Active Directory domain and the exchange system within that data here. This is just because how NTLM works. Wish I could say I was the first one to find this, but I wasn't. Someone else had already put this into Metasploit, and it's in the OWA login module. I am still trying to figure out who found this and put it in the module, and like everyone I've talked to, nobody knows. So if you guys know the guy, I'd like to shake his hand. Okay, identify valid usernames. These are Microsoft recommended usernames. So, and one thing you might notice about them is they all take the employee name and they're just formatted. So this is one of the reasons why it's really important that we gathered those employee names. I'd say 98% of the time, every organization I'm doing work for, they have one of these username formats. It's really rare I'd see A numbers or user IDs being used. It's not, I have run into cases where organizations are using that, but I was able to identify they're using A numbers within the metadata. And at that point, I just generated a big long list of A numbers and was able to validate those accounts using the OWA Timing Attack. So this is a vulnerability that I had discovered, still works, Microsoft hasn't fixed it. I found a time-based authentication hack by monitoring the response times of an authentication request. I ended up finding patterns within these response times, and it would sit here and tell me if the account's actually valid or invalid. This is all the code I use to be able to determine this. I'm quite literally clocking the current system time, making the request, clocking the current system time again, minus the previous system time, and then we're just seeing what the Eclipse time was. Okay, the real issue why this works here is it's the way Microsoft Kerberos is staging these authentication requests. To where, you know, a Linux or Unix system, the way it does Kerberos, it sends the domain, the account, and the password all into a single request to the system. It's where Microsoft Kerberos sits here and it sends one request to the domain. If the domain exists, it comes back and gives it a response, and then it sends it another request for the account to see if the username's in the database, and if that exists, then it comes back and says, okay, what's your password? Looking at some of the time responses on different scenarios here. If I'm sending an authentication request and it's a non-existent domain, I don't know what the domain is, I'm seeing response times come back between 2 to 3 seconds. If the domain exists, but I don't have the username right, I'm seeing these response times to vary, but there's always going to be a pattern there. So let's just say every invalid account comes back within 15 seconds. Okay, if the domain exists and the username exists, I'm seeing all these response times that come back underneath 1 second. So that way we know the account's in Active Directory. Okay, doing timing analysis on non-existent domains. I just kind of wanted to show you guys the pattern here, what I see. So if the domain isn't right and we're sending this authentication request, the very first authentication request is going to come back 2 to 3 seconds. Okay, but then every authentication request after that, and it seems like for 30 seconds, they all come back underneath 1 second. Then you see the 2 to 3 second request again. Then every request after that is underneath 1 second. I believe there's caching being done here on non-existent domains, but this is just good information to know. It's not really going to help us with our hacking. Okay, if we know what the domain is, every row highlighted in green here are valid accounts in Active Directory. The non-existent accounts, they all came back within 15 seconds. And all the valid accounts came back underneath 1 second. By default, administrator and guests are always in Active Directory as default accounts. The guest account, even if it's disabled, but it exists in Active Directory, the response time is still going to come back underneath 1 second. So it'll tell me the account's there. If the account's been renamed. Well, I'd have to know the name. So this is a list of usernames I'm just guessing at. So. Okay, and make sure I got that. So you changed the name on the guest account? Okay, not unless I was able to guess at what you changed the name to. That's the only way I'd be able to validate this. So this whole list in the middle here, this is a common username list that I had built that I'm throwing against the system to see which ones are actually valid or not. Does that make sense? It might make more sense in my demo here too. So now I ended up finding vulnerable paths on the OWA around the timing attack. I found the form-based authentication to be vulnerable on pretty much anything 2007 Service Pack 2 and up. And then I found the static IS file paths to be vulnerable to the timing attack only if NTLM enabled on these paths. By default, these last two file paths have NTLM enabled. Okay, let's do a demo here. Just kind of show you guys some scenarios and okay. So this is a list of usernames that I've built. I don't know if they actually exist in the system or not. We're trying to determine that. So we're going to send one authentication request per account, and then we're going to monitor the response times on these. And anything that comes back underneath the second is actually going to be valid in the system. I'm going to speed this demo up a little bit. Okay. You see how it found the target domain corp? That's because it's built into the module, being able to extract that AD domain. Okay, and we can see the right here in this column is the response times. So the account backup that I was hoping was in the system isn't there. It had a 15-second response time. The help desk account, 15-second response time. Okay. SQL service account, underneath 1 second. And then just for demo purposes, we had training account, underneath 1 second, and as a successful login on that. And I just want to show you guys this next video, and it's just something to think about for what we're going to talk about later in the presentation. Okay, we go to log in with this training account that we popped, and we end up finding out that this account doesn't have an Exchange mailbox because it exists in Active Directory, but it doesn't exist in Exchange. But we can still leverage these accounts, and it's really awesome. Okay, let's talk about identifying weak passwords. This is a typical password policy I'm probably seeing like 75% of the time organizations using. Password complexity enabled, yes. Passwords rotate every 90 days. It's got to be 8 characters. After 5 invalid attempts, it locks out for an hour. But even just looking at this policy here, I can actually do 96 password guesses per an account without locking an account out every day. Because it'd be four password guesses every hour, then the reset timer would get reset. Then I could do 4 more. Something to think about. Okay, if the OWA has 2-factor auth enabled on it, don't worry about it. We can bypass it. Most of the times, I'm just finding out that it's the form-based authentication is the only thing being protected by the 2-factor auth. To where these static IIS file paths, and there's more, these are just 2 examples, they're not protected by 2-factor auth in any case that I've done testing. Okay, doing password analysis over the years, I found these set of passwords to be the most common, to where we're looking at seasons, months, company names, and common dictionary words, right? So, you know, our default password policy, the password's required to be changed every 90 days. Well, what else happens every 90 days? It's a new season. So I'm going to be using winter 2016 all this winter, and it's going to work awesome. I have seen some organizations sit here and think they're doing such a good job on security because they're making all their users change their password every 30 days. Well, it actually makes it kind of easy because now I just got to do the month, right? And then a year or a number. And these are all still meeting password complexity because I capitalized the first letter and added a number to it. Companies, I see company name plus a year. I see company name plus maybe like the headquarters mailing address number. You make up a password. My most favorite one's password 1. It's where you know, a lot of organizations are really good about getting their employees to rotate their passwords these days, but I'm still probably seeing password 1 the most on local administrator accounts. Okay. In this demo here, I just want to show you guys how quick, once we've actually identified a list of valid usernames, how quick our brute forcing attacks actually take now. And this actually turned into an efficiency thing to where, you know, if I got a limited amount of time for an assessment, being able to brute force and extract these credentials speeds up so much. Now I can start advancing my attacks to the internal network. And it was that quick. Versus the other video is really slow because it would take 15 seconds for invalid accounts to come back, and we just brooted several accounts a second or 2. So, okay, let's talk about some, now that we have valid Active Directory credentials, let's talk about some of the information that we can extract from the OWA. I like doing mailbox keyword searches. You know, once I'm in the OWA, I want to know how everybody connects to the VPN. I want to know what the wireless password is. Some cases, I'd see social security numbers and credit cards being transferred between people on payroll, you know. Okay, so this EWS file path here, it's actually the OWA API. You can make requests to it and query it for information. So one of the tools that we have actually queries this API. You only need valid Active Directory credentials. You don't need exchange permissions, and I can extract the entire global address list from the system. So that's every employee's contact information in the system. I can access it. So I only need to do a good enough job to be able to get one Active Directory credential. Then I can extract the entire contact list, and I essentially have all the usernames for the entire organization. Okay, some other information we do, and this is a vulnerability that I had discovered and disclosed, and it's not fixed. It's within the Autodiscover service. And again, we run into a situation where I can use that training account that's only an AD account, doesn't have any exchange permissions. I can authenticate to the Autodiscover service, and I can abuse this using XML SOAP parameter injection that I found to be able to extract the Autodiscover configuration files for any user in the organization as long as I know their email address. Here's the actual SOAP request being sent. Only parameter in this request is email address. And as long as this is valid, I am able to extract the config files. This is the kind of data that's in these config files. It's going to give me the employee's full name. It's going to give me their exchange permissions. If your exchange environment's ever been migrated, and if your company's been around for more than a couple years, I'm sure it has, legacy DN username information is actually getting stored within these Autodiscover config files. And probably the number one thing I like seeing the most out of these config files are the domain controllers, because that's going to take less discovery once I'm actually on the internal network to discover these systems. Okay. So now we know the internal IP addresses to the client access servers, the backend exchange systems. We know where the authenticating domain controllers are at. We've built quite a bit of information about the internal network without even getting onto it yet. Okay, let's go over some email phishing. You guys ever seen that Black Hat movie? Have you seen the where he hacks that NSA guy? Thor hacks the NSA guy with the phishing attack. Well, I was just screwing around just this last week. I was on a phishing assessment, and for me, it was a joke. I was thinking everyone's seen that movie. No one would ever fall for this. So I wrote an email pretty similar to the one that Thor sent. And in the attachment that I had, it's an Excel spreadsheet that's utilizing macros and PowerShell. When the user opens it and tells it to accept the macros, it's loading a interpreter reverse shell back to my box, and now I can start doing my key login and taking passwords just like Thor. Malicious websites. Here's an example of me sending an email to where it doesn't have any attachments. There's nothing malicious about it at all. The only thing I did in this email, I made it very much knee-jerk reaction, like an employee forgot to do something and they should probably do this thing and click this link and just do whatever. You know, a lot of times I'll impersonate that user in HR because that's going to give me a little bit of, trust with the user, where it's coming from. I've been successful with this attack sending it from Gmail accounts. I didn't even bother registering actual domains before. And essentially, once the user goes to this website, it's a fully functional survey site that I wrote, and it's actually just collecting the user credentials when they go to log into it. And a lot of cases, the users are finishing the survey and no one's alerted at all, and they think it was like totally legit. But when I am capturing these credentials, I'm instantly logging into people's emails. I'm monitoring their emails. Okay, and I'm looking to see if anybody was suspicious and they did kick this email upstairs, and then they sent out a mass email to the entire organization sitting here and saying, hey, if you've seen this email, report it and change your password. Well, since I'm monitoring these people's emails, if I see that mass email go out to the whole organization, I want to maintain access for those accounts, so I'm deleting the email that whatever IT security had sent, just so that user doesn't change their password. Okay. Has anybody ever heard of SMTP Catch-all? So Catch-all is an actual feature to where regardless, let's just say I'm doing a phishing attack, and I'm going after rapid7.com. Rapid7.com's the legit customer, and I register a domain, rapid7.co. Well, if I enable Catch-all on my SMTP servers, regardless of what the first half of the email address gets sent to, I'm going to collect and capture all these emails. I'm actually finding people and organizations fat fingering and doing typos to where I'm collecting internal documents just by enabling Catch-all and purchasing a domain. I've gotten internal documents, I've gotten passwords, I've gotten people registering for their Facebook and one email confirmation.
Hello folks, Geek here. Unfortunately, the battery died on the microphone and no one noticed until after the video was pretty much done. So there's no audio for the rest of the video and I'm sorry for the technical glitch.